Hello and welcome back to College Algebra, MAT 150. Continuing with our Week 1 material, review material, we will now look at interval notation. So there are usually an infinite number of solutions for inequalities. We represent those solutions as a set that translates nicely into a number line, and that's called interval notation. Again, because there's so many, we can't just do something like x equals 3 because there's so many more. That's not enough, okay, for our solutions for intervals. And so let's just look at just some interval notation and see why that lines up so nicely with number lines. Well, this reads as the set of all numbers between 5 and infinity. Well, what does 5 and infinity look like on a number line? Well, and to understand notation, go from negative to infinity. And again, we don't have to worry about getting the exact notches of where everything is exactly, but from 5 to infinity, that's all of this stuff right here. And one of the ways you can notate this, it's not the only way, is to put a little bracket right there. And as you notice, 5 to infinity, this translates or associates in very nicely in a one-to-one way what it would look like on a graph. Similarly, now this U thing just means sort of glue together two different intervals, okay, into one bigger set. There's some more implications about what it actually means, but we can avoid that for right now. But if we look at these two intervals, as a matter of fact, -3, and again, we don't have to be precise with the distribution. We'd have -2, -1, 0, 1. We were trying to be a little bit more precise, and then 2, and then 3. Parentheses, again, here we had a bracket with that. The infinity had a parentheses, and we'll come back to that, but the parentheses next to the numbers will have parentheses. The 1 has a bracket next to it. And again, these go in the same direction, and it encloses all the numbers that would be there. 2 and 3 both have parentheses, and we can just shade in between. And again, look how nicely this lines up. So in a more compact way, without having all the stuff in between, we have this interval notation. And that's exactly what interval notation is supposed to be. Make stuff like this more compact. Okay, stuff to represent the solution set of a number line in a very nice and yet still visual way. So how do we write things in interval notation? Well, that's a lovely question. Well, there's 3 major steps, and we're going to go through all of these individually, so for right now. But the steps to find a solution set in interval notation, you do 3 things. And you don't have to do this explicitly, but translate the solution set of the inequality into words. Again, you don't have to actually write it out. We will down here just to be extra explicit, but you don't have to. Then translate the verbal solution set that you just got up in number 1 into a number line. So you read it out loud, then you translate it to what we have before, and then lastly, as we saw, there's a nice one-to-oneness there. Use the graph to find the solution set in interval notation. And we'll give some more details about what some of these things mean here in a second. Okay, so how do we actually read? Well, that's the first thing. The first thing is to start from the variable and read that variable as all numbers. So you're looking at an inequality, and you start reading it. So down here, let me move this really quick. So down here we have an inequality. It says, and it's what's the solution set in words. So looking at this, it says read the variables as all number. So we go to the variable, which is here, and we start reading that as all numbers. So in our minds, we see this. Again, you don't have to normally write this explicitly. We just are just for this one example. So all numbers, and step 2 is just if it's if the inequality is between 2. So we'll come back to that here in a second. But and then basically read in the direction that would be starting from the variable and going towards the numbers. So if the variable's here and the numbers over here, we're reading this way. All right. So all numbers, and when the pointy signs, when you're reading towards the pointy sign, it would be less than. If it was a greater than, we would read greater than. But all numbers less than because it's a strict inequality. And less than what? Less than 2. So everything that's a solution for this inequality is a number that's less than 2. Okay, so all numbers less than 2. All right, so now that we have a way to read this, and again, if it's a number between two inequalities, so something like 3 less than or equal to 3 less than x less than 5, that would be all numbers between 3 and 5 are solutions, is the way you would read that one. Okay? But let's continue. So how do we graph now? Well, so this is where this gets a little bit more interesting. When you're so first off, translate into words as we just did. Then create a number line and plot the number. Again, if it's only one number, just plot it in the middle. We don't have to be too specific about getting out there, okay? Then shade the appropriate region. How do you know what the appropriate region is? From your words. It just comes directly from that, so it's easier to see. And then, if you have a strict inequality, use parentheses, again, hugging the shaded region. If you have a inclusive inequality, it gets a bracket, again, from the shaded region. Some people may have seen in other notations to use holes or filled in dots. That also works just fine. But again, the whole point is to try to get you to this point right here, so it's a perfectly fine notation. All right, so graph the solution set of 2 greater than x. But again, I was reading it from left to right, but we read it from the variable towards the number. All numbers less than 2, which we just translated before on the previous page. And so now, again, graphs, when you make a number line, you go from negative to positive, and you put 2 right in the middle. And if it's all numbers less than 2, okay, again, read from the variable to the number. Is that all the stuff on the left or the right? Well, all numbers less than 2, that's all the stuff less than on this side. So by translating it correctly, you don't have to guess. So that's why you want to translate first. Okay, and because of the strict inequality, we got a parentheses. All right, so we've translated now. We've also took our translation and put it into a graph. Well, let's talk about how to turn that graph into interval notation. Again, it's pretty one-to-one. We pretty much saw the other direction on the previous page. But these are pretty much the only possible combinations you can have in terms of brackets and parentheses. So you could have bracket, 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 parenthesis, parenthesis, bracket, or both parentheses, okay? And to be clear, and this is something a lot of people don't think about, when you're dealing with the strict inequalities, so understand that 1.99 is in fact less than 2, okay? So is 1.999. A lot of people, when they think about these, they only think about what are called integers, okay? But it can be any number. So whenever you see a less than, you can get actually really, really close to that number, but you just don't actually get to that number. Okay, so when you see strict inequalities and thus in association, when you also see parentheses, think you can get really, really, really close to that number, but you never actually get to that number. In contrast with brackets, so versus 2 less than or equal to x, x could actually be 2, and then that would still be a true statement, for example. So whenever you see a bracket, that means you actually reach that number. But whenever you see parentheses, you get really, really close from that side. So from this side, it'd be 1.99. In the other direction, so if you had something like this over here, the closest you could get like you can't really get to 2, but you could get 2.101, 2.001, again, as close as you want from that side without actually reaching that number. All right. So, all right. So having said that, these are all the combinations. One other little thing. So as you noticed from up here, we had the shading went out towards this negative sign, so towards the arrow. So so after you graph the inequality, that's the first step for putting it into interval notation. Well, after you've translated it, of course. When you're trying to translate the shading towards the arrows, if it goes out towards the positive, like here, then you would translate that to infinity. And when you go out towards the negative, that would go to negative infinity. So how would we translate this? Well, again, just like with number lines, it goes from negative to positive, going from left to right. So we start from negative, and we get negative infinity. And then we go out towards 2, which has a bracket. And thus, so the 2 has a bracket up here, so thus we would have a bracket down here. And one last thing to note from this, infinities always get parentheses. So there we go. That finishes it up. And again, if you're wondering why it's a parentheses and not a bracket for infinity, again, the idea is that you go towards infinity. You never actually, infinity is a concept. You don't actually reach it, okay? So this is our interval for this. Well, I'll say never reach it in MAT 150. That's an interesting conversation for another time. All right, so let's do 2 more examples now that we have our tools. Okay. So we have x less than or equal to 3, and then we have this other one, 4 less than or equal to x less than 5. So what did we learn? So we need to translate this into words. We don't have to write it out explicitly, but I'm going to say it. All numbers less than or equal to 3. So we can turn that into a graph. Again, just make a number line with 3 plotted in the middle. All numbers less than or equal to 3, is that on the left or the right? Yeah, it's on the left. And then we have from the strict inequality, or from the inclusive inequality, we have a bracket. And so what does that look like compared to interval notation? Again, go from left to right. How far left do you see any shading? Well, negative infinity. How far do you go up? You go up to 3. You have parentheses. Again, always for negative infinity or infinity, you get parentheses. Now I'm going to put a box around this to indicate our final answer. All right, so again, let's go to this one now. So this one's is an x, or is an inequality with 2 inequalities, right? So x is between 2 numbers. So our solution set is all numbers between 4 and 5. Okay, all numbers between 4 and 5 is this scribbly stuff. And then the inclusive inequality to 4 hugs this, and this strict inequality gives us a parentheses here. So, and this one translates very nicely, 4 to 5, even more nicely than the others. And you could argue that you don't even really need the graph for the double inequalities, so just see 4, and then comma, 5, and then bracket, and then parentheses. But it's usually a really good idea to translate this, at very least to a graph, or especially the first type. And it's also a good way, if you try to do a graph, to show me exactly what you think you were shading in the first place, and as long as you, from what your graph was, you give me the same thing, you might, and if you somehow messed it up on the exam, you would still get partial credit. All right, that is all for interval notation.